Chapter 9, Section 2 considers output determination in the short run. The next section is going to look at output determination in the long run. By focusing on output determination, we're focusing on the decisions of firms, namely how much should they produce. We don't even need to consider how much should they charge, right? Because they're price takers. They have no control over how much they charge, but they do have control over how much they produce. And so that's the topic that's going to concern us now. First, let's look at total revenue. Here's the formula. Simply price times quantity. Here are two figures. The first one, in panel A, plots total revenue at various levels of quantity. And then panel B plots average revenue and marginal revenue, again for various quantities. Let's focus on panel A first. Let's say the price is 60 cents. If you produce 1,000 units, what will your total revenue be? Well, it will be 1,000 times 0.6 equals 600. So at 1,000, we're producing 600. And so on. At 10,000, if you could see this, it would be up here around 6,000, right? So this is just a straight line showing total revenue at various quantities. And because the price is constant, these are straight lines. So this is not supposed to be complicated at all. This is supposed to be really simple. Total revenue is just a straight line. What happens if the price falls, say, to 40 cents? Well then, if you're producing 1,000, you only get 400. If you're producing 10,000, you get 4,000. And this curve shifts down. Right? So this is supposed to be very easy. Now, consider the average revenue. If you're producing 1,000, and you're making total revenue of $600, what is average revenue? Well, you might remember these average and marginal formulas. So average revenue, you should be able to determine is what? Total revenue divided by Q. And so if total revenue is, right here, 600, and quantity is 1,000, then average revenue is 60 cents. In other words, average revenue is just the price. Price is 60 cents. That's also average revenue. You can also see this because what is total revenue? Price times quantity, right? And so you can cancel out these Q's, and average revenue equals price. What about marginal revenue? Well, you'll recall the formula for marginal revenue is a change in something. The formula for a marginal is change in something over change in something else. So in the case of marginal revenue, we have change in what? Total revenue over change in Q. And so let's say we go from 1,000 to 2,000. And total revenue goes from 600 to 1,200. So we have change in total revenue of 600, change in Q of 1,000. Why is that? Because this distance is 600, and this distance is 1,000. And so then the marginal revenue is 0.6. Also equal to the price. And also equal to marginal average revenue. So marginal revenue equals price equals average revenue. This is true for perfectly competitive markets. Next week when we look at monopoly, we'll see that it's not the case. It will be true that average revenue equals price, but marginal revenue won't equal price usually for monopoly. So this is true for perfectly competitive markets. Here we have figure 9.6. Notice on the y-axis we have dollars, and here we have Q. Then we are plotting total revenue and total cost. So recall from the last figure, total revenue is just an upward sloping straight line. Right? Total cost has this nonlinear shape. Why is that? Well, watch the lecture from chapter 8. There are some reasons having to do with efficiencies and synergies in firms that make total costs rise at a decreasing rate initially, but eventually there are too many cooks in the kitchen and costs rise at an increasing rate. So this is the reason for the nonlinear shape of the total cost curve, just to remind you. Where should the firm produce? Remember, this is the whole point of this section. Output determination. How should the firm, what quantity should the firm produce? Let me back up 1 second. What is the firm's objective? They want to maximize something. What do they want to maximize? Green would be the best color to use here. Profit. So we're going to use the Greek symbol pi for profit. Why? Because we use P for price. So pi means profit. And profit equals total revenue minus total cost. So they want to get the highest possible profit. So let me now go back to my last question. Should the firm produce 0? What would their profit be? Well, their total costs are 400. Their total revenue would be 0. So their profit would be negative 400. That's not very good, is it? What if they produce 1,500? Their total revenue and their total cost are equal. Looks like about maybe 600. So what's their profit? We have 600 minus 600, 0. So 0 is better than negative 400, but we still might be able to do better. So if you try every possible quantity and find the profit associated with that, you just pick the quantity with the highest profit, right? It turns out it's right here at 6,700. The distance between total revenue and total cost is 938. That's your profit, right? Total revenue minus total cost is 938. So in other words, when a firm is deciding what quantity to produce, they pick the quantity where the difference between total revenue and total cost is the highest. In other words, where this difference is the highest, right? Sometimes students, because they're familiar with the supply and demand model, they say, oh yeah, I think they're going to pick 8,000 right here, because this is where total cost and total revenue intersect. But that's wrong, right? Because if you just go where the curves intersect, total revenue equals total cost, what's the profit here? 0, right? So you don't want to make 0 profit if you could do better. And here it turns out you make $938. Now, there's a very important mathematical property of this solution. What's the slope of this line equal to? Rise over run, right? Or in other words, change in total revenue over change in Q. What does that equal to, by the way? Marginal revenue. So the slope of this line is marginal revenue, and as we just saw, that equals the price, so 60 cents. Right? What's the slope of the total cost line? This changes, right? Because here the slope is flat, and now the slope is getting steeper, right? So the slope is not constant. With total revenue it is. The slope is constant. But here the slope changes. The slope of the total cost curve is marginal cost. And here's the very important mathematical property. The slope of the total cost curve at the optimum is exactly equal to the slope of the total revenue curve. Now, I don't know if the implication of this is immediately apparent to you. It means marginal revenue equals marginal cost at the optimum. At this optimum quantity of 6,700, the distance between total revenue and total cost is maximized. That means profit is maximized. It also happens to be true, and this is a mathematical fact, that the slope of the total revenue curve, in other words, marginal revenue, and the slope of the total cost curve, in other words, marginal cost, are equal. So when we decide what quantity a firm should produce, we can use two approaches. One, we could maximize the difference between total revenue and total cost, that is to say, maximize profits. Alternatively, we could find the quantity where marginal revenue and marginal cost are equal. That also maximizes profits. It's not as easy to see why that's true, but it is true. It's a mathematical fact. So this is an important figure, actually, because it highlights profit maximizing in two ways. And you'll recall this marginal decision rule. Keep producing as long as the marginal benefits are greater than the marginal costs. You can see that here. At 1,500, you're making zero profit. If you increase production, your marginal benefits are greater than your marginal costs. Until you get to this point, then if you produce any more, the marginal benefit, which is just the price that you receive, right, marginal revenue, is less than your marginal cost. So you should stop increasing production. So you increase production until marginal revenue equals marginal cost. At the point where they're equal, profit is maximized. Figure 9.7 brings together two graphs. The first is the supply and demand graph for the market. And so we're talking about the market for radishes. There are many, many sellers and many, many buyers in this market. The right-hand side, we have the cost curves for an individual firm. So while on the left we have the market, on the right we have just one firm. And we can characterize this firm by their cost curves, right? The production technology is embodied in these cost curves. If the market price is 40 cents, what quantity should the firm produce? Well, we know that they should choose their quantity based on marginal revenue equals marginal cost. So if the price is 40 cents, this is determined in the market, right, by the interaction of supply and demand. So we go over to the firm, find 40 cents, and find where does that intersect the marginal cost curve. It turns out right here. And so then we go down and we read off the quantity, 6,700. So when the price is 40 cents, the firm should produce 6,700 units. At that quantity, they earn a profit. How can you see this? Well, again, profit is total revenue minus total cost, right? Well, what's total revenue? It's price times quantity, right? And so we know that the price equals 40 cents, and the quantity equals 6,700. What about total costs? Are total costs shown anywhere on this figure? No, they are not. But what is shown is average total cost. So let me write the formula for average total cost, and then you'll see where we get total cost from. So average total cost equals total cost divided by Q, right? So now if we want to get total cost by itself, we can just multiply both sides by Q, and then these cancel, and we have quantity times average total cost equals total cost. When we're producing 6,700, what is the average total cost? From this figure, start at 6,700 and go up until you hit the average total cost curve. That happens right here. Then go over to find out what it is. Turns out it's 26 cents. So total cost equals 26 cents times 6,700. Another way that you could write this is that profit equals 6,700 times 0.4 minus 0.26. What do we call this here? You could call it the average profit, or the term profit margin. So this is your profit margin. It's about 14 cents, right? So for each unit you sell, you're making 14 cents profit. And you're selling 6,700 units. So your total profit is 938. You can check the math. But what's important for you now to see is how can you tell this graphically? So let me go through this again. The price is determined in the market. It's 40 cents. The individual firm says, how much should I produce? Well, at 40 cents, I maximize profit by choosing the quantity where marginal revenue equals marginal cost, which is right here. And the quantity associated with this profit maximizing point is 6,700. My total revenue is 6,700 times 40. So this big square is total revenue. My total cost is average total cost times quantity, or 6,700 times 26. So this is total cost. The difference between those is profit. Total revenue minus total cost. In this figure, something bad happens to the farmers. The demand for radishes falls. Why might the demand for radishes fall? Well, from time to time there are news reports that highlight positive or negative aspects of certain products. Maybe a news report comes out and says, radishes contribute to baldness. So people stop eating radishes. Or any number of reasons, right? Could cause the demand for radishes to fall. Maybe the price of a substitute, like a turnip, goes down. Who knows? For whatever reason, demand falls. What happens to the price? Falls. From 40 cents to 18 cents. What is our firm going to do? Well, at a price of 18 cents, marginal revenue equals marginal cost right here. That tells the firm they should produce 4,444 units. So this is the profit maximizing quantity. But what is the profit? Remember, profit equals total revenue minus total cost. And so total revenue is price times quantity, right? 18 times 4,444. This blue box is total revenue. But what is total cost? It's average total cost times Q. So Q, again, is 4,444. But what are average total cost? Well, when you're producing 4,444, average total costs are given by this point here, which we see are 23 cents. So this green box is total cost. This green box is bigger than this blue box, right? In other words, profits are negative. Here you have a loss of $222. So what should the firm do? Should it exit the industry? Here's the problem. This is the short run. It can't exit the industry. It takes time for a firm to exit the industry. They have to put their factory up for sale. And it's going to take time for them to find a buyer. So, because we're talking about the short run, some of their inputs are fixed, probably their factory. So they can't exit. So the question that they should ask then is, should I just stay open and minimize my losses? Or should I just shut my doors and wait for someone to come along and buy my factory? It turns out that decision, the answer to that question, hinges on whether the price is above average variable cost. And we see that it is. Because average variable cost is here, 14 cents. The price is 18 cents. And so what that means is, when the price is 18 cents, you're not making a profit. You're not covering all your costs. But at least you're covering your variable costs. That means you're paying your workers, you're paying for your inputs, and everything that you need to produce the product. And then you're making even 4 cents on top of that. So those 4 cents per unit that you're making on top of that, you can use towards paying your rent or whatever it is. Let's say you have a long-term lease on this factory. So you're paying your rent. It's not enough to pay all your rent, but at least you're helping to pay the rent. So in this situation, the firm should stay open in the short run until you can find someone to buy until you can exit the industry. But if the price falls even more, this is figure 9.9, and it depicts shutting down. So here the price falls even more. Remember, there's a market that determines the price, right? Radishes get even more bad press, say, and the price falls even more. So now at a price of 10 cents, Marginal revenue equals marginal cost right here. The firm maximizes profits or minimizes losses, which turns out to be the same thing, by the way, at 1,700. But there, they're not even covering their average variable costs. So this 10 cents is not even enough to pay for the seeds and the workers. So you should just shut down right now. Lock your door. Put an ad in the paper saying, somebody come buy my factory or my farm. When they finally do buy your farm, you can exit the industry. But until that happens, you're going to shut down and just have to pay your fixed costs with no income coming in. But that's better than operating, right? Because if you operate, you're basically subsidizing the radish production and then selling them for less than you can produce them at. Okay, this is important. The fact that a firm shuts down when the price is below their average variable cost yields the following result. And so this is important. Where does the firm's supply curve come from? It turns out the firm's supply curve is their marginal cost curve. But not the entire marginal cost curve. Only the portion of the marginal cost curve that's above average variable cost. So this is the firm's supply curve. And why is it a supply curve? Well, supply curve tells us at any given price what quantity will the firm produce, right? That's what a supply curve tells us. Turns out this tells us the exact same thing. Therefore, it is a supply curve. If the price is 15 cents, the firm's going to supply 17 units. Right? So that's why that is a supply curve for an individual firm. If all the firms are identical, and say there are 20,000 firms, and the price is $10, they're each producing 14, what's total output? You have 14 times 20,000. That equals 280,000. And that's what you see right here. So at a price of $10, total quantity supplied in the market is 280,000. If the price is $20, an individual firm will produce 19. But there's 20,000 firms, each producing 19. And so what we have is 380,000, or this quantity right here. Now it turns out at 15, an individual firm produces 17. You should have 340 here. But the reason they have 330 is because they want this to be a straight line to make it easier for us. So we just have straight line industry supply curves. So it's potentially confusing why it's 330. But they are making an approximation here. So if you only knew these 2 points at 10 and 20, and then you connected them, you would have a straight line. All right, so quickly, what are the most important concepts from this section? First of all, in a perfectly competitive market, marginal revenue equals average revenue equals price. Then, here we see that profit is maximized where the distance between total revenue and total cost is the greatest. Or in other words, where profit is the greatest. And it just so happens that the slope of the total cost curve and the slope of the total revenue curve are equal at that point. In other words, marginal revenue equals marginal cost when profit is maximized. We also saw how a firm takes a market price as given, determines what quantity to produce, and also determines its profit. We saw how changing prices in the market, for example, that were caused by demand shifts, can cause the firm go from making a profit to making a loss. And in fact, there's one more important concept that I'd highlight to you, and that is that the portion of the marginal cost curve above average variable cost is the firm's supply curve. And then, as we already know, we sum individual supply curves together to get the industry supply.